Okay, I'm gonna turn the proceeding over to Leslie Asher, who is acting as our moderator for this panel discussion. This is the first time we've done this in the United States. We have done it twice at Arab Lab at Dubai. It's been very good. And Dario, I think, was part of that twice, right? Yeah. Yeah, excellent. Yep, we did panel discussion there. And so the group has been meeting periodically for the last 5 months or so, and they did say they wanted it to be conversational, but I actually want it to be confrontational. So before they had these, meetings, sometimes I would show video clips of the Jerry Springer show to them. So you're going to hear some stuff. They're going to start pulling each other's hair. And I was going to hire bodyguards like Jerry Springer has, but we didn't do that. With that, I'm going to turn this over to Leslie. There is a microphone on the side there, the stand, to my left. And after the discussion, you can get up, go over to the microphone. This room is so big, your voice won't carry enough, and you'll be able to ask questions or have comments. So with that, I'll turn this over to Leslie. Leslie Asher.
Thanks, David. Hi, everybody. David wants us to talk smack and all that. We're nice architects. I don't know that we're going to do that, so we don't want to let you down. For those of you I haven't met, I'm an architect with HOK Architects. I'm one of the firm-wide directors of science and technology. For 25 years, I've only done science and technology-based laboratories. I've been blessed to work all over the world. And so we've got a panel of people here who also are working on laboratory projects all over the world. And we're here to talk to you about things that are happening on projects that we work on, because we get to see things that are going to be coming down the pipeline before the manufacturers, installers, et cetera, get to. So we thought it would be a fun opportunity to talk to you about that. I'll have each of you guys introduce yourselves. Don't forget to turn your microphone on. Randy?
Thanks, Leslie. My name's Randy Cray. I'm also with HOK and a firm-wide director in science and technology. I have the pleasure of being a partner with Leslie in that venture. I've also been working for about 25, 30 years on science buildings. My career started in Canada, but I emigrated to the US, to Atlanta in 2000, and have had a wonderful career since then based out of Atlanta. My work the past few years has taken me both across the US and internationally. I've done several projects in the UK. Actually been working in the UK probably without stop for the last 20 years. My work is mostly institutional based, both higher education and government projects in the animal and human health sector, as well as a lot of biomedical. And lately almost all my projects have had some aspect of interdisciplinarity to it, not just straight biomedical, but medicine, engineering, chemistry, and so forth, and probably something that I'll talk a little bit about as we get into some of our discussion today.
I'm Lloyd Fisk with Research Facilities Design, managing principal at RFD, and I run our Raleigh outpost in North Carolina. Much as is the case with Leslie and Randy, I've focused my entire career on planning and designing laboratories. It's also been about 30 years. I started my career actually at a company that was called Kling, and then became Kling Stubbins, and then became Jacobs, working at that time primarily working on projects for the pharmaceutical industry, so for Merck and Glaxo, which was a great place to sort of cut my teeth on laboratory needs and requirements, working with very sophisticated clients who had built many labs themselves, and also to work with great scientists who were doing great work on human health issues at that time. And then a transition to RFD 18 years ago. Many of you know at RFD our work is mostly institutional, as Randy mentioned, his work is. Meaning universities, government institutions, private research institutions, some of which are very sophisticated clients and some of which are not. So having a breadth of experience to bring to those projects is certainly something that's often useful. And again, I think I look forward to chatting on some of the other topics Randy brought up as we actually dig into the conversation.
Yeah, hello, my name is Dario Tonelli. I'm the managing director of Laborplaner Tonelli. And our office is a lab design office, a small lab design office in big Switzerland. And our journey started 20 years ago. We started with small project planning school laboratories, and since then we further developed. So the project get bigger, the company get bigger, the requirements get also higher, and so we further developed on this project, mainly in Switzerland, but we also do project in foreign country like Germany, France, Finland, and Singapore. So because Basel is the hotspot in Switzerland about innovation, lab design, because it started about 15 years ago with Novartis. They were pushing the limits in lab design. Once it got a bit quiet, it rolled over to Roche, and so they continued. And we had the chance to be, and also to help to further develop this innovation. At the moment, we have the PRED Center in Basel. This is just shortly will be finished in a few weeks. And for us, it was a really long time. Also, it was over 10 years that we could work on that project and learn about innovation and also about future-orientated concepts.
Good morning, everybody. My name is Brian Richard with Kirksey Architects. I'm the Director of Science and Technology Projects there. I've been working on laboratories and technical projects for about 24 years now. Our practice is really diverse, private side companies all the way to institutional clientele. And we stretch from life sciences to a concentration in chemical laboratories. And even now, semiconductor fab and some clean room type facilities. So really interesting practice, and happy to be here today and looking forward to the conversation with everybody.
All right. Thank you. I am Diane Case. I'm Senior Laboratory Planner for Smith Group. I've actually been in the industry for more than 30 years, I hate to admit, and it's my first boss was actually Earl Walls, so it's nice to see people in the room here who actually remember him. I started there as a drafter. I came right out of college and started as a draftsman and worked my way up. I now work with Smith Group, and I straddle both our S&T studio market and our higher ed market. Right now I'm doing most of my work in the United States, which is really great. I'm glad to be back after being in the Middle East for over 10 years. I'm glad to be back. Most of my work is in the Connecticut area, Michigan. I've got a government project that I can't really speak much about in New Mexico. And then the bulk of my higher ed work is actually out in California. And I think that's it. Thanks.
Great, thanks everybody. So we've got a series of a couple of questions that we've developed, hoping that they're topics that you would want to hear about. The first one that I want to bring up is we all know that the world is changing at a very rapid pace, and there are those that say we're into the fourth industrial revolution. I don't really know, have never counted, but we all know that the world is changing at a very rapid rate. Everybody's talking about AI and things like that. But I want to talk to our panel about if you've experienced any shifts in the focus of what your laboratory projects have and what some of those shifts are. So we'll start with Diane. Just randomly picking my friends here. Diane, what have you seen that are some changes in the laboratory types and focuses on your projects?
So the change in laboratory type is actually, especially with battery technologies being at the forefront right now, the need for dry lab space, which is very unique and and complicated. So that's the main thing that I see right now. Whether or not that will be around 10 years from now or a need for that 10 years from now, don't know. Unless they can find a way to make the batteries less volatile, I question whether or not that's going to continue. But that's what I'm seeing more of. And then there's also, there's the higher ed. There's always the need to get students through their education at the college level. So there's always a need for those instructional laboratories that just can, get the students through. So I'm seeing a lot of that still. That'll never change, I think.
Brian, you've got the microphone now. You want to share that with us?
Chosen by default because the mic was passed to me. I guess one thing, I'm not on the batteries, but on AI, since you mentioned AI specifically, we have seen very recently people ask us, well, I'll back up just a second. Traditionally, there's always been the wet lab bench space and then your computational space. That's, primarily existed in the room next door or down the hall or something like that. We have been asked very specifically, can I put my computational analysis people in the laboratory environment? And so that's sort of a change, and our immediate response is, well, why do you want to do that? And do you understand the impacts of that? Some of which are positive, some of which are negative, right? But the positive, at least in response from these particular clients that we're talking to, is we want AI to move so fast. We need an immediate interaction between what those guys are working on and how that translates to what happens on the wet bench. And so we don't want the separation. And so we're sitting here thinking, man, the latency of just walking down the hall, is that too much? And their answer is yes. There's no reason to have it. Let's eliminate it. So why can't we do that? And so I found that to be an incredibly interesting impact of kind of something new that we had not heard being requested before.
Okay, thanks. And Lloyd, you're working on projects spanning the whole globe. I think you've got things in India and the Middle East and Asia. Any difference between what you're working on there and what you're working on in the United States?
Well, yeah, certainly there are differences in how those projects are delivered. In many cases, there are differences, very significant differences, in terms of the client interaction process between sort of projects that are delivered in the U.S. with a more traditional facilities group running the show versus what often happens in those other countries where projects are a bit more dynamic. In terms of sort of laboratory design types and laboratory concepts, if you will, or the types of labs that we're seeing primarily, one thing I will say is, a lot of the simple research lab types are out there in large numbers. If you're looking for a nice basic biomedical research building to do work on cells and tissues, there's tens of millions of square feet of those buildings across the U.S. Some of them are in need of renovation, certainly, but some of them are quite new. So what we're often seeing on higher education campuses now is universities are looking to build buildings that solve the next tier of challenge, if you will. And in many cases, sort of as Randy mentioned, and Brian as well, they're interdisciplinary challenges where people are doing computational work in the same room as work with animals, or doing fluidics work in the same room as working with materials. And those certainly do start to prod at this beautiful notion of open lab and lab support space that we've been so successful with for 20 years, because a lot of these interdisciplinary research projects do have stringent vibration controls, environmental controls, light control issues, and because of interdisciplinary, they also have complicated security access issues and training issues. So that's certainly one issue we've seen, and certainly many campuses right now, if you're not aware of it, have very significant applied physics research buildings, either in design or in construction, including, we're working on the one at Yale, Princeton has a very large one, UPenn has a very large one, Chicago has a very large one in design. And so again, sort of thinking about the next level of challenge, like getting down to research at below the scale of an atom, right? below the scale of things that you can even possibly see. And this very much links into AI because, of course, quantum computing comes out of all that work in physics. So that's certainly a lab type that we're going to see some amazing results in the next 5 or 6 years as this next generation of buildings comes online. And it does present challenges, certainly for this industry, because for the most part, even though these labs have some casework, they're not casework-driven laboratories, right? Many of them are open field spaces in which structures need to be built out of, Bosch systems and things of this nature. So understanding a challenge, I think, on a lot of these projects is understanding what part of that structure is base build that some of the people in this room might work on versus what the owner is just going to do after they take over the building. Again, that's something we're looking at on all those projects.
So we need to get an extruded aluminum manufacturer on the CIFA membership. Randy, how about you?
Well, there's a lot that's been said already, and to try to not just pile on with another unique perspective, I think that a lot has been talked about is right in what we're seeing. I do want to focus on the interdisciplinarity that I'm seeing exploding, especially in higher ed, and the intent to try and couple higher ed with industry in terms of, again, solving the grand challenges of health, climate, and things like that are far too complex for just a single disciplinary perspective. So we're seeing projects that are trying to mash together as many types of disciplines, and especially bringing together basic sciences, medicine, and engineering together under the same tent to try to not only create knowledge, but turn that knowledge into applications and new therapeutics or new types of technologies, such as clean energy technologies. And so two things happen there. One is we can't predict what kind of team, the ability to say this is the type of research that's going to happen in this building for the next 15 to 20 years becomes kind of a fool's game to try and think that you have that kind of crystal ball. And so the problem is how do we create as flexible and adaptable and interdisciplinary research platform as we can. So we need to find solutions that allow for the cleanest of applications and the dirtiest of applications to potentially be in the same building, the lowest vibration needs, and things that really are about systems engineering and bringing together and making things which has very little sort of high performance requirements to it. So I would say that one of the things that's happening is the workplace outside the lab is becoming really important in terms of where we know that collaboration can happen. I mean, the only Jerry Springer moment we might have here, David, is I think I challenge the notion that getting AI scientists into the wet lab is really the solution there, because I think that we also find that those data scientists, they have their own tribe and they want to be able to collaborate amongst themselves and solve computational problems. So we're seeing more, how do we allow them to have a core of computation, but also be integrated in with the wet researchers and the experimentalists. So I think that we need to really rethink the adaptability of the lab platforms as much as we can afford to, and also be able to really work on that, the kind of scientific workplace outside the labs where much of that collaboration will happen.
Okay, so Brian, you either going to throw your microphone at Randy or you want to talk?
Well, we were supposed to throw chairs, but David, these are heavy. So Randy, thank you for that. I'm not sure it's the right answer, right? So that's for sure. It's just a question that's being asked. But what I did want to add to that for just a second is, how does that relate to manufacturers? How does that relate to all of you who are making the things that go into the laboratory space? It used to be that when we talked about these very specific spaces, that we wanted something, whatever that something is, right? A fume hood, a biosafety cabinet, casework solution, whatever. We wanted to do something very specific to apply to that, whatever type of space that we were designing. With these interdisciplinary spaces that we're now talking about that have to be flexible in use, the specificity, if I can say that word correctly, of an item is still important, but it is as equally important that we ask a manufacturer, don't prevent me from doing something different with that product. And so that is very important for lots of things going into these lab spaces that all of you guys are talking about now. And so we want you to keep that in mind, right? So when you're making something, when you're thinking about the new version of it, don't prevent us from doing something different than what you actually intended. There's obviously a reasonableness limit to that, but that's important. That's going to be required moving into the future for the flexibility of these spaces.
Okay, thanks. Dario, if you look at labs from the 1900s, and I'm specifically talking about like Thomas Edison's labs, I don't know if everybody's seen those, but you can Google it and see what his labs look like. You'll see that they were modular. Everything was in rows, the fume hoods were around the perimeter, the benches had shelving up above. They were not significantly different to what we're doing today still. Some recent changes have been adaptable modular systems, things that can move up and down, adjustable shelves and all that. So there's a level of flexibility that's been added in to laboratory furnishings. But if you got out your crystal ball, what would you say is going to be the next big thing in laboratory furnishings and equipment? What do you see coming in the next 10 to 15 years?
And do you remember the labs from the 1900s?
Yeah, I built them. Now, I was astonished to hear that they already had the thinking about modular design. I mean, that didn't change today. I think this is the clue for giving or getting the flexibility. I think what changed is when we're looking back just to the old structures of laboratories, there are small-scale laboratories. So if you see, there are in a building many kingdoms. So every research leader has his own kingdom. And I think this is the problem what we have to change today. And this is, I think, sometimes we are the bad guys when we talk with the user and the management because we will change. And what means that to change away from small scale into open space laboratories where we have more possibilities to use synergies, to more find the collaboration between the researchers, and also get a well-being, and also having visibility. I think this is what we want to try also with the new concepts, to change that away from the kingdoms that people have to learn to share the devices so we can optimize, we can make the spaces more efficient. Also about the running time, when we hear the running time of the devices is about 10 to 20%. With using the synergies in creating open space laboratories, we can optimize. But we don't have to forget that when we do open space, this is at least in Switzerland, we cannot have open space and then build the furniture up to the ceiling. So this is a big request because of safety, that we always have to see the visual reference into the escape ways. And that, for me, a big advantage. Also to discuss with the lab users, because they want to have at their space everything. So even the storage, at best even up to the ceiling. I think we don't want to have that. To solve the problem with a good logistic concept, we solve that and make also the space more efficient and not misuse it as a storage space. And I think this is the way we should go. Planning the new laboratories, new concept, further develop what we have today into innovative concepts that we have a building that in 30 years is still attractive.
Mm-hmm. So you're talking about the P-Red building has just-in-time delivery.
Exactly.
So there's in the basement level, right, is all kinds of storage of things that are then rapidly delivered up to the laboratory, so they don't have as much shelving. It's a much more open. It actually feels like workplace.
Yeah, it's not just the P-Red. We are doing that since many years already. So with a shop like the university in Switzerland was the first institute where they started, and was about 50, 20 years ago, where they had like a shop, but not like an automatic delivery over a conveyor system or like a tube system. This is what we have at the
That might
Pierrette.
be very exciting with some chemicals.
Huh?
Right? That might be very exciting with some chemicals to have them shoot through a tube.
No, not through the tube system. That doesn't work. But with a conveyor system, it works. So Pierrette Center has 35 floors. How you build a logistic that is functional and safe. And so we had many discussions with the authority because they were afraid, because they don't know that. And so we have to build up trust and also to show the safety with a risk analysis that this is not a problem. So I think we can further develop also like these concepts.
Diane, you've got your microphone ready?
I do. So I wanted to bring it on the higher ed side. What we're seeing a change in is there's been the movement recently about having flexible middles, and so all the gas services, water services are on the perimeter. Well, we're having some clients that are saying, no, we really want the services brought down to where the students are working, but we also want that area flexible and reconfigurable. So that's a dilemma that we're starting to see, and we need to task the manufacturers in helping us come up with a solution. And we're talking, gas, air, and vacuum, plus power, plus data. All those services. Whether or not we could get the sinks out there, I doubt that, but at least the dry services, they're requesting that, but they're also requesting those flexible middles still.
I'd like to comment on Dario's point about open labs, and I love open labs as much as anyone, and I think every project needs some amount of open lab space to create in many ways, honestly, just to create a floor plate concept. But I will say a lot of the clients that I'm working with right now, some of the largest projects, we're finding as we really dig into the scientific procedures that occur, that the vast majority of them occur in lab support spaces, be it tissue culture, microscopy, electrophysiology, high-throughput screening, many other things. This is especially the case in fields like neuroscience, where most of the work needs to be in enclosed rooms. So it becomes something of a planning challenge, where you have a big bar of labs, if you could imagine, on a floor plate, and on only little small pockets of open lab space, and then trying to work on strategies to map the utilization and sharing of those lab support spaces is another challenge in that project type. So again, that's not across every project, but certainly a lot of the projects that we're seeing now that are looking to, if you will, interdisciplinary research, or if you want to call it more complex research, that's the rebalancing that we're seeing between lab and lab support space.
So this is something that Randy's been very involved with benchmarking for a very long time, and looking at the trends that influence the lab support, the typologies. Randy, what do you want to add about that?
Well, I'll say, first of all, I think you're both right. We need those open labs because we need the socialization. We need the sense that it's not, lab space isn't an entitlement. You get to put your name on a room and say, this is my lab, come in if I invite you in. That this is a institutional asset and being used to the highest utilization possible, as Dario talked about. But we're also saying I think if I've heard one phrase more than anything else for the last 2, 3, or 5 years, it's we don't have enough tissue culture space. I think that was something that we missed as planners in terms of the growth of tissue culture in bioscience-based research. It's just and then those other technologies. So I think that our challenge as planners it needs to be, how do we create that right ratio of cellular to open, flexible research space? But make sure to the degree possible, it isn't owned by anyone unless it's really a specific, bespoke built piece of apparatus that one researcher is using. But it's more of a universally accessible sort of platform or system. I think actually we got to get away from the term lab support, because I think a scientist who does most of the work in tissue culture is saying, that's not my support lab, that is my lab. And I think that we as a discipline probably need to rethink the words we're calling these things. Lloyd and everyone, at least I've been thinking lately that those lab typology words I've been using no longer kind of are relevant. I don't know how important that is to the people who are actually building the real things, the physical things that go in these labs. But I think the idea that these cellular rooms, I think a more universal concept of the cellular space that can be fit out as tissue culture or as microscopy or as other functions. We need your help to how we can build that universal adaptability, because I think we're seeing a move back to cellular to the reasons you said, but they've got to be used in a different way than the old way, which was there was a 600 square foot room that was a bit of a fiefdom from the principal investigator standpoint.
So besides changing our terminology, I've always been very triggered by the term wet lab and dry lab, because I don't think that all dry labs are actually dry. And dry lab is a different, so usually when I start a project and people want to use that terminology, fine, I will get a definition of what they call a dry lab, because it might just be computational. And I always say, if you can have carpet, is it really a lab? By our definition, I don't think we're going to have a carpet flooring group as part of CIFA, but we'll see. One of the big disruptors, though, that we can talk about that I think that the manufacturers would really want to be involved in is the need for modularity of like prefab things. Randy, you've got a prefab project going on right now. Do you want to tell us what you're doing with that one?
Well, yeah, I think that's where the conversation leads to is, as we're seeing at least some types of research environments evolving today, we're seeing a repetition of a room type, especially when we want it to be modular, adaptable, like not singular in its potential function for the end user, for the owner. That coupled with the labor shortage we're seeing today in many marketplaces, and the fast track kind of nature of much of our projects, and the volatility in terms of labor marketplaces, we're starting to see the business case for pre-manufacture of modular lab space to be actually make sense, and we're using it on a project right now for an institutional client in the Northeast, where there is too much work going on and labor shortage and so forth. So clearly, we're trying to incorporate the architecture, the shell, the finishing, the engineering systems, all pre-built in a warehouse somewhere and then shipped on site and moved in. It changes the relationship of the walls to structure, because you all of a sudden can't be putting wall centerline on columns. You know, these rooms have to, be slid in between the structural sort of free area or inside dimension. But I'm really interested in, again, how we can build these as pre-manufactured adaptable labs to be able to take the type of systems that you're providing into it, either built in the warehouse and moved, or else be able to be plugged in once those rooms are brought on site. I'm very interested in that as a new way of building lab space, because we're seeing a common repetition of a room type happening more now.
And quite a few of our manufacturers have pre-manufactured walls in segments, and that's a very repeatable thing that can be brought in. And that actually touches kind of on the point of sustainability in laboratory spaces. So whenever we can have walls that are something that's relocatable and reusable, similar to the furnishings, we're not tearing it down, ripping it out to move things around, and it adds flexibility, and it doesn't add to the landfill waste. So Diane, you wanted to talk a little bit about the sustainability aspects, and
it was actually more about
the
the health
Okay.
and wellness, and that was one of one of the discussions that we had in our S&T group a few weeks back was just going back to the computational thing. They can sometimes work from home, and so post-COVID, it's been a struggle for some of our clients to get those individuals back into the lab. So that's one challenge that really I don't think we can solve here. But in terms of the wellness, I think it's important, for those people that do have to be on site for 8, 10, 12 hours, however long they're on site, it's providing them with amenities, with places where they can go for respite. And we have some clients that have just gone to I wouldn't say the extreme, but they really care about their employees, and they care about the health and well-being of their employees, both from a physical standpoint, but also the emotional and mental standpoint. So I think that's going to become more critical. I don't know that it really impacts a lot of the people in the room here, but that is something that I think is important that our buildings in the future start to really consider. And yet those seem to be the first spaces that get cut when we have budget overrides. And so I think it's just something that we do need to start focusing more on, especially with the talent shortage that's out there. I mean, everyone is feeling that. So in order to attract those individuals, we got to make the environments very comfortable and welcoming and engaging to be working in.
Mm-hmm. So we're learning some lessons through the things that tech companies have done to attract employees and retain them, that having some of those amenities is really critical. Some of those things that are outside the labs, but then having the things inside the labs also are critical. Brian, do you have things in your labs that you think are addressing some of these things?
I do. I have two comments on sustainability, and perhaps both of these might actually spur some discussion here. So the first is specifically as it relates to what all you guys are making in terms of product. We do a lot of renovation work, and when we go in and we demolish an existing laboratory space, where does the stuff go? Landfill, right? So more often than not. Sometimes there's a reclamation effort, sometimes there's a reuse opportunity. More often than not, it goes away. So not that we're not all conscious of sustainability, it's been that way for quite a while, but as we continue to move forward in the future, that as a whole needs to be addressed, the amount of stuff that we're putting into a landfill. I can sit up here and say, wouldn't it be great if all of you guys took back everything you put into a lab? Easier said than done.
Isn't IKEA doing that?
Yeah, well, but how do we figure that out? That is the question, right? And so we as architects and lab planners are going to need your help to figure out the right answer, the right solution to that problem. We can't just keep putting stuff into the ground. So none of us have the magic bullet, but collectively we can figure out what that right answer is. The second point I have to make on sustainability, I'm going to use an analogy here in a second with a data center. Research is a numbers game, right? So when you're talking about R&D, the more opportunities you have for discovery, the more likelihood there is of you making that discovery. So as you translate that to actual products and items in a laboratory space, more is better. Historically, we have often talked to clients about, do you really need 2 fume hoods? You could do that in 1 fume hood, right? And so why do you need 2? Just to oversimplify the concept here. That remains, that should always remain, but the fact also exists that if you do have 2, you have 2 opportunities to discover something instead of just 1. So my point here is that we also need to be evaluating the ability to make products more efficient so that we can use more of them. The analogy I have for you guys of the data center is just imagine these huge data center projects, for whoever, Facebook, Alphabet, name it. They don't want less computers. They want more computers. Like laboratories, data centers are energy hogs. We're not going to eliminate that as what a laboratory is. It'll always use energy. But we do need to find ways that it uses less energy. So we don't need to decrease significantly the amount of items, the amount of equipment, the amount of product that we actually have going into the space. We want to afford the research team the maximum ability to be able to use the most pieces of whatever it is that they need to solve the problem that they're after. So 2 comments there. Thanks.
Dario, anything to add to this?
I agree what Brian was saying. This is what I feel also right now with reusing the lab furniture. Even if it costs more to reuse it, they will do it just because of the reason of sustainability. And this is what we feel more and more in the project, that this is a big issue. But the other thing, I think, social sustainability, this is what we experience in Switzerland a lot. because the battle of the pharma industry, but also of the university, is so high to have like an attractive place, not just become to Switzerland and skiing and nice chocolate. It's to have a nice place to work there, because it's not just the salary what attracts. This is, I think, this is gone. It's more the workplace, also like the value what the client gives to the employees. Just enter the building and have the wow effect. You have the latest, the newest concept, how you can work, how you can collaborate. And I think this is very important, what I experienced. But we did also some bad experience, to be honest, that over-designing is a risk. And it happened if the management doesn't hear sometimes to the planning team. So I think it's a very important point, the social aspects, to create also this interdisciplinary exchange, not just on the floor, but also in the building. How can we bring people together and that they have to talk? And I always bring the example, the coffee machine. The coffee machine is very important. Not having on every floor a coffee machine, you have it on the right spot where the people have to walk there, where the people have to meet each other. And this is what we try also to integrate in our concepts.
Yeah, thank you. Lloyd, any things that we haven't even addressed yet that you want to make sure you share with everybody?
Oh, well. But I'd like to, I mean, certainly this discussion about common space and amenities. Now, as a lab planner, I don't design common spaces and amenities, but I certainly admire many of the ones that are put in our projects. And one of the trends that I'm seeing in the latest buildings, I call it the domestication of the lab building. This trend of kitchens with islands, for example, in science buildings, which you would never have seen even 10 years ago. But also very consciously thinking, I mean, Dario mentioned this, of the sort of social engineering of the building, right? So like the Gates Center in Seattle is an example where they put the coffee on the top of the building. So everyone has to go up to get it, while, other projects, like you're saying, put it in a stack or put it on every other floor. But really thinking about how common spaces get people to move throughout the building, to interact and to collaborate, is really essential. But also thinking about the neurodiversity of people that work in these types of buildings. I mean, I don't want to generalize myself, but I've had this conversation with many deans and scientists, chairs. Scientists are by nature mostly introverts, just as a statistical average. So getting people to break out of their little boxes and giving them different opportunities to do that, but also giving people places where people can go tuck in a corner and hide away if that's what they need to do for a period of the day to get a break, is all part of sort of thinking about how all those spaces work together to support a really great science building. And there's no doubt the projects we're doing at places like MIT and Princeton and Yale and Moffitt Cancer Center, very much in this sort of recruitment issue, and very much focused on making buildings that people just feel wonderful spending many, many hours of their days in. So that's absolutely essential.
Randy, what laboratory furnishings and equipment solutions do you see that would address some of these things that we're talking about? The wellness in the lab, the neurodiversity, that everybody can't be in a loud place all the time. You have head-down focus space.
Well, let's start with the lab. I think that, the first point I want to make, which is general, is your design matters. That the equipment, the furniture, the systems that we select and that work functionally and meet the standards and the performance standards. Also, your attention to design and beauty and the visual aspect of them really matters and makes a difference. And scientists might not admit that design matters. They might feel like, I don't care. Just give me something that gives me the data I need, and that's probably true to some degree. But I can tell you from experience that the ability to recruit scientists in a place that's beautifully designed and detailed, the data is there that the effort that you do and we collaborate with you on makes a difference and achieves the end results that our clients are looking for. I think that we've seen a growth in the ability to think of the laboratory environment as not just a white finished space. There are some times when a white lab is stunning and the right thing, but we've also seen the ability to bring color and biophilia and pattern and that into the line. So I think that's also important essentially for different types of people and for a different qualitative space. So the ability to have choices from a visual design standpoint with our lab environments, I think is something that we need to continue to encourage. I think it comes out of the lab then, Leslie, in terms of, one, I think we talked a little bit about transparency. We might have, but we should make sure that that's mentioned, that the ability to connect the space outside the lab with the space inside the lab, to be able to draw natural light through as much of these environments from every direction we can and create view corridors. Those are our most successful labs where people feel good and can work in and stay energized. And then I would just agree with everyone, what you said in that about creating the right different types of environments. So you have a workplace environment of choice in terms of the way you want to do the tasks that you have to do in any given time. Because someone will feel most comfortable going to a really busy coffee area where there's tons of people and noise and activity to do thinking work, and other people will need to find that quiet, reflective space in that. And then so we need to ensure that we're providing all those environments so that the discovery and the translation to benefits for society can happen.
Fantastic. I think we have time to open it up for some questions. There's a microphone in the back, as David mentioned. But what if nobody goes back there, David? Do you want us just to talk? We're architects. We have no trouble just filling up space and talking.
While we're waiting for the first question, I do have another thought on the sustainability topic. This might sound so simple to everyone in this room, but I still think one of the challenges that we see is inappropriate use of fume hoods. People using fume hoods basically as exhausted enclosures to locate, be it ovens or other pieces of equipment in them. And I think one of the reasons that this happens is that there are not easily available cataloged products on the market for exhausted enclosures. You can make them out of Bosch systems if you want. And there are, Flow Sciences makes a limited number of such things of different sizes. But I think that's sort of a missing piece, and I suspect that the fume hood manufacturers think those things are too simple to tackle as a product. But again, there are many things that people do in fume hoods, things that they just leave sitting there for years on end, don't really need to be in fume hoods. And I think that's something that we certainly try to push back on when we're looking at instrument rooms and things of this nature.
We don't have any questions?
So here's the microphone. Come on up, Dawn.
David, you should have taken it to her.
This is a real English accent. Okay, this is not a phony English accent.
I'm going to do an American one. So with not just AI, but the advent of more robotics, do you see the floor plate changing and obviously furniture solutions with it?
Well, I'll give a few thoughts on robotics. So within the academic sector, where we do most of our work, the application of large-scale robotic analytical systems is not prevalent. They're very expensive, not currently that easy to purchase, and from a funding perspective at academic institutions. That said, there are a few exceptions. The most significant exception that I'm aware of, because we're working there, is Carnegie Mellon, that's putting their Emerald Cloud Lab online, which is bigger than this room, automated analytical system. So certainly systems of that scale look very different from anything that would fit in a typical lab space. The degree to which those technologies become prevalent across a range of project types, in my opinion, is yet to be seen. But I think on the industry side, for example, you'd see more of that than you do in academia.
I think, again, another conversation that we've had internally at Smith Group was just the introduction of AI and robotics and whether or not it will impact the lab size. And I think, in my opinion, right now, no, I don't see it changing the lab floor plate. While there's robotics out there, in terms of them actually taking the place of humans, there's a long period of development in terms of that technology and making sure that there's safety for those. If you are having robots that are in the lab working, you know, I forget what the company is, but they're those big yellow things that are just very dangerous. And if you get too close, they'll wipe out a human. So until we can get those types of robotics that can actually acknowledge that there are people nearby, for the safety of the people that are working in the lab, because there's always got to be some sort of human oversight. Until AI can, rule the world, there's going to have to be human oversight. So for now, we don't see the size of the lab changing and much of the casework changing right now.
So one thing to add, I agree today. The answer is no. But there's a mountain that you can see, on the road that we're on that's down the way a bit that is just ahead of us that we know we're all going to have to cross. I would add, though, as one thing we have been evaluating, because lots of equipment is available today that is kind of a robot or a semi-robot, right? It's basically in a box and it sits on a bench. We have been we've had internal discussions about, not even considering a 30-inch top anymore, of just going straight to 3 feet deep, just to accommodate the size of things that might be available in the future that are simply unknown today. And that does affect your lab module, obviously. So I don't know if any of you guys have had those similar kinds of discussions. We love the 30, but it's not as deep as the 36, right?
So things aren't getting smaller?
No, unfortunately, yes, they are not. They're getting more technologically complex, but not smaller.
Interesting, not yet.
I'll just add that, like many things, we're seeing on the more national investment level, bigger systems that are, and we're involved in some in the material science area where there's very long robotic systems that are trying to incorporate artificial intelligence and material science, manufacturing and analytics to try and perfect the systems sort of in real time. And so I don't know if that's going to translate to other types of research environments, but on the more national investment level, some national labs we're seeing some of that happening, which is making us create frankly removable partition, a series of rooms for smaller systems to be designed and developed, but with the potential to retract walls in the laboratory so they could create a 100-foot long linear system if they needed to as they start to bring these modules together. That was the outcome of that design problem.
Jonathan?
Thank you. Is it on? Hello? Yep. California has become the first state to enforce this embodied carbon emissions control for the building code. Do you envision that, I suspect you do, to spread in other states? And how do you envision that affecting perhaps your lab design in the architectural community?
Don't jump all at once, guys.
First, yes. It is important. It's a hard thing to track, right? So there's, I don't know if controversy is the right word, but controversy in how you calculate that. It's not clear. There's no consensus on how that all works out. But on two fronts, both from a legislative standpoint, building code or what have you, we do believe that some of that is in the future and how those will be rewritten. And then from a ESG or corporate standpoint, we have clients that require certain standards just because of their own requirements, their own internal requirements. They have to be able to say X, Y, and Z. And there is no deviation from that, for what it's worth, guys. So we need to comply with that more often than not, 99% of the time, when they have those kinds of requirements. So it is something, I think it's one of those things that is not quite figured out all of the way yet, but is definitely something that we're all dealing with. Wouldn't y'all agree? Yeah.
I also, sorry. And to add to that a little bit, because I do have a project in California, in San Francisco, and San Francisco has a no gas. I forget what the term is. Sorry, I'm drawing a blank. They don't want any natural gas use in their buildings. Everything has to be all electric. And there's a trade-off for a building being all electric. But one of the things that we found in our study and in our analysis about whether or not our facility could go to all electric is there are just certain processes, especially on the arts side, that we're finding. Like, for example, firing kilns. There are just certain materials that do need gas because the electrics can't get to the temperatures that are needed to fire and create that process with certain materials. So we still had to add some gas into our facility, unfortunately. But they also are one of the leading ceramics instructional institutions in the area. So it was important that they maintain their curriculum.
So there are exceptions to that, no
Yes.
natural gas. And that's good for us because the electricity that's required to, say, for an autoclave, a pass-through, the large cage washers, the bulk cage washers and bulk autoclaves, is like the equivalent of a small city. To do it all by electricity. There is a biotech company in San Francisco that is currently doing an all-electric animal facility. It's not built yet, so I'm kind of dying to see what happens with that. But it could be that what started in California stops there because it didn't work. I don't know. We'll see what happens with that one. Randy?
Going back on the embodied carbon issue, 2 points. One is it is really important if we're taking climate change seriously that not only sort of operational carbon but also embodied carbon is something that we do everything we can. And one of the things that we understand or see is that it's the structural aspects of the building is a significant part of the embodied carbon. So although everything that is in this room has to be looked at carefully too, as architects we're really studying whether or not more sustainable structural systems such as timber frame construction that is possible for a science building. And there are challenges there indeed. But I think that looking at the question of the embodied carbon analysis for our projects, we're going to see more adaptive reuse and more use of existing buildings. The case to demolish a building to build a new science building is going to be harder to make, and it's going to mean that we're going to be asked to find solutions in older, less floor-to-floor situations in that. And so so all of our systems are going to have to get as tight and miniaturized and as efficient as they can from a space standpoint. And then we're going to be looking at alternative methods for building the structure and enclosure for new facilities, including local materials, et cetera. So I think that should be added to the conversation about the embodied carbon question.
Kurt, do you have a question?
Yeah, very, very interesting conversation. I'm wondering if you think that these megatrends will, in fact, increase the demand and need for laboratory spaces. So, for example, with AI, since our end product isn't digital, it's not like the movies, right? Our end product, the AI might get to the point of a lot more innovation in chemistry research, but at the end of the day, someone's going to mix chemicals together, someone's going to create a new compound, someone still has to do all that work. It could increase the amount of lab space that's necessary as opposed to decreasing it. Right now there's a big demand maybe for making the aluminum 80-20 frames, but at the end of the day, I just wonder if you think it could be more laboratory space. And Diane was mentioning also about the volatility of battery technology, for example, and we've heard earlier that Sasha is going to be working on that in our storage areas. So I think that these new mega trends actually could increase the need of what SEFA does and provides. And I just wonder what you thought about that.
It's a good point. When I started working on laboratory facilities 25 plus years ago, my first projects were animal facilities, and I remember hearing, oh, we're going to have less and less animal facilities, less use of I've seen nothing but more animals and more specialized spaces for animals. So, the megatrends, I guess, people can say what they say, but they don't really know. Have any of you got any experience with new types of laboratory spaces that, AI is not going to be solving for us anytime soon? Brian's ready to go.
Quick on the trigger, I guess. Not exactly quite answering your question, Leslie, but we have been, one of our clients we're having an ongoing discussion with about what the impact of AI will be on their research space. And it all revolves not around replacing human beings, not around decreasing laboratory space, but instead on ROC, if you guys are familiar with that acronym. It's rate of change. And so what AI does is makes everything faster, right? So it allows you to analyze a lot more stuff way quicker than you normally would not have been able to do, which ideally will result in more innovation and more discovery quicker than we've done in the past. Well, whenever we make a discovery, we also typically create 10 new problems for ourselves that all need to be researched and have their own answers to those. And so to answer your question, we don't see it going away at all, replacing, and we would agree that the need is likely going to increase as a result of that phenomenon. So the impact on rate of change of what AI is going to bring is going to be something that we're very anxious to see. But we truly believe, I mean, it's going to result in more laboratory spaces and more need as a result.
Mm-hmm. And new types of laboratories, Kurt. So yes. Quantum laboratories are laboratories. They're not using ones and zeros to compute things. I don't even know how they work, but they take a very special kind of clean room, which is great for all of us. Let's build more clean room laboratories to do quantum computing and development and quantum precision measurement, all kinds of quantum things. So it'll keep us busy for a little while.
Yeah, and I'll just add to Brian's point, just from my personal perspective, the most sophisticated computer science project that we're working on is the new MIT Schwarzman College of Computing, which will be opening shortly. And MIT was very explicit when we started working with them that they didn't want a building just full of computer scientists. Their interest was what is on the threshold between computer science and chemistry, and computer science and biology, and computer science and medicine. Yeah. So actually 2/3 of the building is designed for what we call applied computer science, looking at those interactions, those interrelationships. That'll be interdepartmental research projects versus the other 3/5 that's essentially pure computer science. So that linkage, taking an idea from a concept to something that's commercializable, that goes through all the typical lab types that we've always worked on. Yeah. And they're still absolutely going to be required.
Fantastic. Abby?
Yeah, I just wanted to go back to the sustainability and recycling topic. So our company was asked to do a project for Intel, and it was an interesting thought that I thought might be applicable here. It was very successful. They wanted to look at clean room materials, and as you know, clean rooms have a lot of hazardous, chemicals and stuff like that in there, but they asked us to come up with a program where had several components. One is they were doing a demolition of a very large, building to bring in new technology, but they wanted us to determine how much of the architectural materials would be reusable and possibly recyclable, sort of those two categories. And then they set a standard that was not a very high standard, which I thought was also interesting, because they did a calculation and felt like and they do a lot of, every 5 to 7 years, renovating the entire factory, that if they could reuse or recycle approximately 15 to 25%, it was a tremendous impact. So that's the benchmark that they gave us. And it was amazing because it changed all the way the demo teams worked, right? Because now they were going to get an incentive if they demoed out everything, whatever it was, casework, ceilings, walls, floors, and they were able to give it back to this program. They were, contractually going to get a financial incentive to do it. And then also the new project renovation team was going to get an incentive to use those materials. And it's been in place in New Mexico for quite some time, and also now moving to their fab sites in Acatia, which is a gigantic site in Arizona. And it's been very successful to manage it and reduce the waste from those demo jobs tremendously, which was also getting extremely costly in those two locations to even get a place where you could dump this kind of stuff without actually also having the history of what chemicals it was exposed to, treating it, cleaning it, et cetera, and so forth. So it's been a really interesting program, and I think for some of the big university systems and Department of Energy labs and things like that, I think it could also be very helpful. So kind of taught us a different way to look at it. You guys may have some experience, so.
I don't have any experience with any of that, do you guys? Seems like a great thing to do.
Yeah. We can always have something to add. So thank you for bringing that up. It is important. So we did 2 projects for Pacific Northwest National Lab in Richland, Washington, Abby. And they did not implement programs that you're talking about, but those discussions were had on both those projects at the beginning. And that's a DOE site, right? So that's, their hurdle, I think, was how do they maintain the program? Like, who owns it? Who's the enforcer? And how do they manage it? Like, they couldn't answer any of those questions. And I think if there were an organization or a system in place that allowed them to figure that out, they would have proceeded with implementing some design aspects on both of those projects in that way. So for them, that was the hurdle. It wasn't that it was a bad idea or they didn't know what the end result would be or how to even get started. It was just how to manage it through the process. So,
yeah, we used our construction team to implement it. The design team kind of came up with it, the architects, but the construction team actually implemented it on behalf of the owner. So
cool.
That's an idea, perhaps.
Okay, well, we need to wrap up. We've got other things on our program today, so thank you to our esteemed panel of architects, and look forward to doing this again. Thanks, everyone.
Great, thank you. We're going to take a 10-minute break and reconvene at 11:45 for the presentation of the Lab of the Year finalists. Thank you, everybody.